So here is another question on solving quadratic equations through quadratic formula method. So here the equation is given. Solve p square x square plus p square minus q square x minus q square is equal to 0. So here p and q, they are real numbers. So here it is slightly different. Instead of actual numbers, we have p, q like that, where they are real numbers. So we have to solve it for x in terms of p and q. Okay. So here first we'll write the equation as it is: p square x square plus p square minus q square x minus q square is equal to 0. So here if we compare it with the standard format of quadratic equation, ax square plus bx plus c is equal to 0, here a is equal to p square, b is equal to p square minus q square, and c is equal to minus q square. So here, as per the quadratic formula, the roots of the quadratic equation, they will be the two roots minus b plus minus root of b square minus 4ac by 2a. So here first we'll calculate this discriminant b square minus 4ac, because then it will become simple. Otherwise, if we'll do this calculation here, it will become very complicated. So first we'll calculate this b square minus 4ac, which is the discriminant d. So b square minus 4ac is equal to p square minus q square whole square minus 4 into p square, 4 into p square is lagging a bit, sorry, 4 into p square into minus q square. Okay, so this is equal to p square whole square plus q square whole square minus 2p square q square, and this is minus minus plus, it becomes plus 4p square q square. Okay, so now we have this equal to, we'll keep it as it is, p square whole square plus q square whole square, and this is minus 2p square q square plus 4p square q square, it becomes plus 2p square q square. So this is the expression of a plus b whole square, a square plus b square plus 2ab. So we can write it as p square plus q square whole square. Okay, this is the discriminant, p square plus q square whole square. Now we can easily calculate the values of the roots of the quadratic equation. So the roots are alpha beta is equal to minus b plus minus root over of d by 2a, where d is equal to b square minus 4ac. So here it is equal to minus b. So b is p square minus q square, so minus p square minus q square minus b plus minus root over of p square plus q square whole square by 2a. A is equal to p square. So 2p square. So this is equal to, this is minus p square plus q square plus minus p square plus q square whole square, root over will be simply p square plus q square by 2p square. So this is equal to, one of the roots will be equal to minus p square plus q square plus p square plus q square by 2p square, and the other one will be equal to minus p square plus q square minus p square plus q square by 2p square. These are the two possible roots. So for the first one, it is equal to minus p square plus p square will get cancelled. So q square plus q square, it will be 2q square by 2p square, which is equal to q square by p square. 2 will get cancelled, so we have q square by p square. And for the second one, it is minus p square will be minus 2p, and q square minus q square, it will get cancelled. So q square minus q square will get cancelled, so here will be minus p square will be minus 2p square by plus 2p square, which is equal to minus 1. Okay, so the two roots, they are, let's say this is alpha, this is beta. One is q square by p square, and the other one is minus 1. Okay, these are the two roots of the given quadratic equation. Okay, one in terms of q and p, other one in terms of a number minus 1. Okay, so here is another question on solving quadratic equations through quadratic formula method. So here the equation is given 36x square minus 12ax plus a square minus b square is equal to 0. Okay, and we have to solve it using quadratic formula method. So here first we'll write the quadratic equation. So we have 36x square minus 12ax plus a square minus b square is equal to 0. This is the given quadratic equation. So if we compare it with the standard format of quadratic equation, here I am using capitals. Okay, ax square plus bx plus c is equal to 0, because there is small a small b, so I am not using the same format ax square plus b, I am using capital A, B, C. So if we compare it with the basic format of quadratic equation, we have a is equal to 36, b is equal to minus 12a, and c is equal to a square minus b square. So here, as per the quadratic formula, we will determine the roots of the quadratic equation, which will be phi beta, which is equal to minus b plus minus root over of b square minus 4ac by 2a. So here b square minus 4ac is called as the discriminant. Okay, d. So here first we'll calculate the discriminant, b square minus 4ac. So it will be equal to minus 12a whole square minus 4 into 36 into a square minus b square. It is equal to minus 12a whole square, it will be equal to 144a square minus 4 into 36, it will be equal to how much? Same 144, yes, 144. 30 into 4 is 120 and 120 plus 24, 144, yes, 144 into a square minus b square. So here it will be equal to 144 a square minus 144 a square plus 144 b square. If we open the bracket, it becomes minus 144 a square plus 144 b square. So this gets cancelled, 144 a square minus 144 a square. So we have the discriminant equal to 144 b square. This. So the two roots of the quadratic equation, it will be equal to for beta equal to minus b plus minus root over of d by 2a, which is equal to minus b is minus 12a plus minus root over of 144 b square by a is how much? 36. Okay, so 2 into 36, which is equal to 12a plus minus, this will be 12b. Okay, 12 square is 144 and b square root over is b. So 12a plus minus 12b by 72, which is equal to 12 common a plus minus b by 72. This is 6. So the two roots are a plus minus b by 6. So one of the roots is a plus b by 6 and the other root is beta a minus b by 6. These are the two roots of the quadratic equation. Okay, so this is the thing.